Hello everyone, it's Mohammad Akil and Mohammad Ibrahim from Team M2 with a project demonstration on Tyre Air Pressure monitor. Let's start off with the need analysis of our project. We have all faced this problem of flat tire at least once in our lifetime. There may be some situations when we are on a highway and our tire is flat and that there are no shops nearby. In this worst case scenario, we have to call for help from a mechanic who would reach our location after a long time. When this happens, there is no other go but to wait. And this is where our idea comes into play.
Moving on to the development of the model has two phases. The first one is the development of the solid model, which is done using the software SolidWorks. And the second one is the development of the Android app, which is done using the Android Studio application. Now, let us see the development of the solid model. This solid model has a bigger tire, which is nothing but a conventional two-wheeler tire. This tire has two cylinders in its center. These two cylinders hold in an inner cylinder which is shown here in black in color, and this inner cylinder has an additional rod which is in contact with the tire. This additional rod and the inner cylinder is filled with water, which helps us to check in the air pressure that's there in the tire. Also, this inner cylinder has another rod that is connected to the tire, which helps in inflating the tire in case of puncture. There are two slider rods present on either side of the tire. These slider rods support extension rods on both the sides, and these extension rods at its ends carry the additional wheels, which is going to support the vehicle in case of puncture. Initially, the additional wheels will be at the topmost position, and this main wheel will be supporting the vehicle for its running. In case of puncture, the main wheel will be inflated, which is done with the help of an application, and these additional wheels will be lowered to the lowermost position. This lowering is done manually, and this is not a tedious process, but it is done by simply removing and inserting the bolts. Moving on to the simulation of the components, let us first see the simulation of the additional wheel, which is going to bear the entire stresses in case if the main wheel is punctured. In the stress analysis, we find that there is no red color region in this diagram, indicating that there is no extreme stresses occurring in this additional wheel. Moving on to the displacement analysis, we see that there is a red color region at the outer periphery of the wheel, which usually occurs and is not a great issue, and we see the simulation for it. Moving on to the strain analysis, this strain analysis again has no red region in its body, indicating that there is no extreme strain positions in the wheel. The second component that we are going to analyze is the extension rod that is going to bear the wheel. In the stress analysis, we see that there is no red color region, indicating no extreme stresses are occurring. In the displacement region, there is a red color region at the bottom, and also we could find some movement in the bottom portion. This is not of a greater issue because additional loads at the bottom will be taken care by the additional wheels which is going to support this extension rod. Moving on to the strain analysis, here too we don't find any red color region, indicating that there is no maximum strain occurring at any part of this extension rod. The third component that we are going to analyze is the roller bars. These roller bars bear all the rolling stresses that is going to occur on lowering the extension rod using roller wheels. Here again in the stress analysis, we find no red region, indicating there is no extreme stresses. In the displacement region, there is a red color region at the bottom and also certain displacement occurring in the simulation part. This again is of no much importance because these downward acting stresses will be taken over by the extension rod, in turn taken by the additional wheels which transfer the stresses to the ground. In the strain analysis too, we find no extreme strain occurring in this component. This is going to be the tube that is going to connect the inner cylinder with the outer tire and contains water in it to measure the air pressure of the tire. Here, the pressure of the air acts in the inner portion of the cylinder, and this again causes a slight displacement in the downward portion in the stress analysis, but no extra stresses like extreme stresses act in this position, and in the displacement region 2 we find some displacement occurring at the downward position, and also in strain analysis we find there is no extreme strain that is going to occur here because there is no red color region indicated in this diagram, and again certain displacement is there in the extreme position. These displacements are of no importance because this downward position will be inserted to the tire, and the displacements will be arrested by the hole that is put in the tire and will not cause much damage. Let us now see the 360-degree rotation of the solid model and the extruded view of the model in order to get a better understanding over the parts that's being used in the solid model. Moving on to the detailed analysis of the working mechanism, first let us see the working mechanism by which we are going to measure the air pressure in the tire. Let us consider this part as the inner tube that's going to connect the tire and the inner cylinder, and this part be the tire. Now initially in the tube connecting the tire and the cylinder is filled with water, and the tire is filled with air molecules. Now if the air pressure in the tire reduces, then a low pressure region is created here. The water from the tube now goes down to this low pressure region, and thereby the water level in the tube decreases. And now this decrease in the water level in the tube is identified with the help of a sensor and is seen in our mobile applications. Moving into the second working mechanism, the mechanism through which we are going to inflate the tire in case of puncture. This is the second tube which is going to be in connection with the cylinder at the center and the outermost tire. This plunger will be at its lowermost position, sealing the air of the tire and does not leave the air to escape. When the tire gets punctured, we through an app activate this plunger and this plunger moves up. As this plunger moves up, air from the tire moves into this plunger, thereby inflating the tire. This puncture keeps on moving up and will remain at the topmost position until the puncture of the wheel is rectified. This is a simple circuit using Arduino to show how we would sense the amount of air pressure in the tire using an app. This Arduino receives the signal, and this is going to be the part that connects the circuit that is connected here and the phone. Micro servo also helps the Arduino circuit in connecting with the phone. And this is a sensor, ultrasonic distance sensor, which is used in measuring the level of water in the tube, which indirectly measures the amount of air in the tire. This battery supply is just given as 9 volt for an example. Actual battery supply could be taken from the battery of the two-wheeler itself, which doesn't add any additional cost. This is a simple LED which we assume as the display of our Android app. On starting the simulation, we could see that This sensor receives the signal from the water level and transfers it to the circuit, which in turn transmits the signal to the application in our mobile, which displays certain unit. Here the coding has been done to show simply the numbers of 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is the second circuit which helps us in operating the plunger to inflate the tire in case of puncture. This 9-volt battery is again put as a representation. In actual case, we would connect it to the battery of the automobile, and this Arduino receives the input from the app that we give. And this micro servo unit also helps us to receive the signal from the application. After receiving the signal, which in case we click and start simulation, we would see the motor running. This motor is just a representation of the activation unit that helps us to pull up the plunger and push in when it is in off condition. Moving on to the second phase of the design, that is the design of application. We have designed this using the software Android Studio. We have two layouts for this design. The first one is the main layout, which will be a home screen, and the second one is the layout which is going to show us various informations and which helps us in controlling various mechanisms that we discussed previously. Let us see in detail about the working of the app. Let us now see the working of the Android application. Here we find our application Tyre Air Pressure Monitor TAPM. On clicking the application, first we get the login page where we have to enter our product ID, that is the ID that is there in our purchased product. It is nothing but text. Let me simply type some text and click on sign in. When I click sign in, first I get the status at the top right corner. If the device is connected with the Android application, it will show status as connected. If it is not connected, it will show as disconnected. Then the 70% here shows the amount of air pressure in the tire. Now it indicates that in the tire 70% of air pressure is there. If it is reduces to a certain amount, we could go and we could pump in air. The next option is for inflating the tire in case of puncture. If there is a puncture, we will just switch on this, which could activate the mechanism, that is the plunger mechanism, which we saw in detail. On activating it, the tire will get inflated, and after the tire gets inflated, we will switch off this. And we have added two images of our product for better aesthetic, which shows the product at normal working condition and at the condition after puncture. And we are Mohammed Akil M and Mohammed Ibrahim who developed this project. Thank you.